Okay, we're recording, and now I'm going to talk about the absolute value of a number. Absolute value of a number. So if x is any real number, we write x inside these, and that's equal to the absolute value of x, sometimes mod x or mod of x. Yeah, you see different notations for it. And how is this defined? Well, mod x equals x if x is greater than or equal to 0, and minus x if x is strictly less than 0. So you'll see here that we cover all bases. Bases, I guess. Because it's positive, it's this one. If it's negative, it's that one. And if it's equal to 0, it's this one. We could equally say equivalent to mod x equals, it's a lot easier to say mod x than the absolute value of x. X if x is strictly positive, and minus x if x is less than or equal to 0. See how I've taken the 0 from one to the other, which we can do. That's mod x. And if you draw it, it looks like this. If I go whoop and draw a nice little pair of x, there's x and there's the y-axis. I'm going to draw y equals mod x. It's not very neat, is it? Let's try that again. Oops. Difficulty with the pen. Mod x. Then it looks like this. I'm trying to draw it 45 degrees. Junk. Okay, y equals mod x looks like that. So of course you've got y equals x here, and you've got y equals minus x here, and they meet at the origin there. So the most basic inequality of all is that for any x, mod x is greater than or equal to 0. And I guess the proof is as follows. If x is positive, then mod x equals x, which is greater than or equal to 0. If x is not, actually I'll write it out slightly differently. I'll say x is not greater than or equal to 0, which implies that x is strictly less than 0, which implies that mod x equals minus x, which is also greater than 0. Done. So therefore we've covered two bases here. There's a little subtlety here, which is there's two distinct schools of thought here in inequalities. The first one, two schools of thought. Number one says for any x, mod x is greater than or equal to 0 with equality, which of course means that mod x equals 0 if and only if x equals 0 exactly. That's the way I like to write it, simply as I said, because my writing, I find that a much more agreeable symbol to write than the strict one. I don't like that. But there's another school of thought which you see in older textbooks, which says that for any x, mod x is strictly greater than 0, except when x equals 0, where we have equality. Two schools of thought here, and I find it annoying that there's these two ways of viewing it, and I find it's difficult. What we mean, you see, this one's a better way to say it, but this one's more accurate in a way, because this, if I say mod x is greater than or equal to 0, you're kind of implying that, well, it might be equal to 0, or it probably might be less than. Oh, but it's and then you need this extra part that says it's equality only if and only if x equals 0. Surely the important thing is that. And then you say, well, that's not always true, is it? Because if x equals 0, the equality kicks in. So, but both of these are rather messy ways of expressing the same. Messy. But we've got to get used to it because it occurs throughout the whole of the study of inequalities. Okay, so take home message: mod x is greater than or equal to 0 with equality if and only if x equals 0. And this is a prototypical inequality, and I'm going to stop there.